Hey Stat class, we're going to talk about probability distributions in this video. We just did binomial and geometric, and now we're doing the probability one, and we're going to look at number 20 on page 221. Now what a Poisson distribution does is it looks like the word poison, but it's actually Poisson, that's French. And all of these distributions are summed up for you on page 219. But what the Poisson distribution does, it says, what if the average, which is mu, is a certain average, and we want to find out, well, what if it's not that average? What's the probability that it's something else? What's the probability that it's higher and lower than what they said it is on any particular day or given year or whatever? So what we're going to do is we're going to look at number 20, and it says this. The mean number of organ transplants from living donors performed per day in the United States in 2016 was about 16. So what they're telling us, in that year 2016, every day, on the average, 16 people were donating their organs. It's saying, but they're saying find the probability that on any given day that it is exactly 12. So maybe they want to make a projection, or they want to know that it would be 12 for the next year, at least 12 or whatever. So what we do is we say, well, what's the probability that x is equal to 12? And we use this formula. Now, mu is our average, so that's 16 to the 12th, which is what we want. This is what it is, the average. We're saying, well, what about if it's 12? We use E. Now, this E number is, as we discussed in class, and if you had pre-calculus, it's this number 2.71828, and it goes on and on. This number is a transcendental number like pi, where the decimal place continues on, and I'll show you how to use that on the calculator if you don't know. And this is going to be a negative average, which in our case is going to be a negative 16. So it's e to the negative 16th power. And we're going to divide this by 12 factorial, which we used last chapter, so you should be kind of familiar with that. Question, how do we put this in our calculator? Well, let's see. If we have 16 to the 12th, you know how to use your exponent button, which is right above the divide sign, right? 16 to the 12th. You can hit enter now, or you could go times, and we're going to multiply this by. Now, if you want to be extra careful and put parentheses around that 16 to the 12th, you can. But in this case, if it's multiply, the calculator will understand it. But I'm going to do it just to get in the habit. So I'm going to go back, and I'm going to put parentheses. I'm going to insert, second insert, and I'm going to insert a parenthesis around that. To tell the calculator I'm keeping that together. It really is more for division problems. We've seen problems with this. I'm going to go times E. Now, E is, we're going to go second, and behind the natural log, ln button, we're going to go second, we're going to go ln, and on our screen, it'll say to us e to the what? The calculator is waiting for us to tell it, e to the what? In our case, it's e to the negative 16. Now, don't put a minus 16. We want to come down here and go negative 16, right? And then we would have it looking like this, and we're going to close the parentheses. Then we're going to divide this. You can hit enter now and then divide. We're going to divide it by 12 factorial. So we put in our 12. And then to find factorial, what we're going to do is we're going to hit math. And then we're going to scroll over to probability, because that's what we're doing right now, probability. And we're going to go down to the fourth one. You can hit a number 4 or scroll down to it and hit enter. And then it'll say I just dividing by 12 factorial. And if we hit enter, the answer comes out to be 0.066. So you can try this at home and make sure that you get 0.066. This is part A to the problem. Part B now, they get a little bit trickier, and they say, what's the probability? Where is this problem? What's the probability that it's at least 8? So if we put the probability of at least 8 let's think about what this means. It's the probability. At least 8 means it includes 8. If I say I have $8 in my pocket, if I say I have at least 8, that means I have 8 or more. And 8 or more looks like this. X is either 8, but it could be equal to 8 or more. That's where the greater sign comes in. So what I'm going to do is, this is actually, well, it's actually the probability of 8 plus the probability of 9 plus the probability of 10 plus the probability all the way up to 16, right? So at least 8, it could actually mean on and on and on and on, right? So it's 8, at least 8, it could be 100. The other thing we could do is we could go 1 minus the probability of 1 plus the probability of 2 all the way up to probability of 7. Now that would mean we would have to do this formula over and over again. This is a complement, so 8 to infinity, it would be the same thing as 1 minus probability of 1 to 7, because they're complements of one another, because all the probabilities are going to add up to 1. Well, we don't want to do this 7 times, and we don't want to do this an infinite number of times. Even though the higher you go, you'll start to zero out on some of them. But what we could do is we could go to page A15, and we could look at page A15, and we can say, oh, they have this set up for me. The Poisson distributions are like from A12 to A15. And what we have is our average is 16. So along the top, if you notice, we have averages, and we want the one that says 16. And this one would be 12. For part A, we would go down to 12, and we would look over, and look at that. There's our 0.066. I hope you can see that. But in this case, I want to do 1 to 7 and add them together without doing the formula over and over again. So I'm looking up 1 to 7. I'm going over to where my average is 16, and I'm going to add all these up. Now the first 2 or 3 are zeros, right? But I'm going to add these all up. And if I add those all up, I'm going to get a 0.01. So all of these will come out to be a 0.01. And then we're going to go 1 minus 0.01, get 0.99. If we get 0.99, that's the answer to 8 or more, or at least 8. So it's going to be 1 minus 0.01. And we did that with the aid of the table in the back of the book, so we didn't have to use the formula over and over and over again. Now the last part to this problem is part C, where it's the probability of more than 10. Probability that X is, less than or equal to 10. So if we're looking at that problem, and it says no more than 10. No more than 10. No more than 10 seems to imply that it includes 10. No more than 10 is okay if you have 10, but less than that. So that means we're going to want the probability of 1 plus the probability of 2 plus 3 plus 4 plus 5 all the way up to the probability of 9 plus the probability of 10. And we're going to have to do this formula over and over and over again. Instead of doing the formula, when you have a problem like this, we look to the table in the back of the book. And we want the probabilities of 1 to 10. We want the probabilities of 1 to 10 when the average is 16. And off to the left, we want to add all these up from 1 to 10. So if we slide over, I did this one in orange, and I would have to add all of these numbers up. That would be no more than 10. No more than means it excludes all these. No more than 10 means just from 1 to 10. And if we add those up, we get an answer of 0.077. Try this again on your own. Try the same exact problem, number 20, work through it, and then try to do all the other ones, all the other odd ones, in the section 4.3, page 221, in that Larsen Farber textbook, 7th edition. I will see you next class.